So we are Team MASIC. Our team members are Josh, Robert, Daryl, and myself, John. And the problem that we're tackling is that of the insulator flashover due to contamination. This contamination can be anything from salt to acid to even fine dirt. Our device is the MASIC device, the MASIC system, which stands for Monitor and Alert for Substation Insulator Contamination System. And basically, our system will detect contamination buildup on the insulator and then send a message to the power industry, power companies, that they can go and clean these insulators on demand. The current solution right now is to schedule cleanings at set time intervals. However, ours will be able to do it on demand, which will not only decrease costs of unnecessary cleanings, but as well as provide additional protection against power outages. There is one other competitor who has a similar device. The advantages of our device, though, compared to the other, is that ours will have wireless communication versus their wired communication, as well as their device would have a battery, and ours would be locally tapped into the 120, 240 volt AC distribution panel, which will then be converted to 5 volt DC via a buck converter. And then Rob will go over into more design specifics of the sensor.
So basic idea here is this is an example of a 15 kV insulator that a utility would use. And essentially we would mount sensors on the sheds of the insulator here, and our control circuitry would present a voltage potential to those two different points. And if there was sufficient contamination buildup on the insulator and in wet conditions, you're going to have a leakage current pass from one point to the other. And our control circuitry would sense that leakage current, which would indicate that this insulator would need to get cleaned. The idea that this insulator would be mounted on the buswork within the substation at a similar orientation to the utilities insulators, however, would be a safe enough distance away as to not cause issues with the other high voltage lines present in the area. The beauty of our system is it is scalable and adaptable to any different type of insulator design or voltage level, but for the sake of our prototype, this is the particular insulator that we would be using. And control circuitry would be mounted nearby in an ABS plastic housing, which would pass the information on to a microprocessor located in the control house, which Daryl's going to explain now.
Our device will include a microcontroller that will take measurements from our sensor. It will also have a temperature humidity sensor and a GPS sensor. The microcontroller would take our measurements from our sensor and the temperature humidity sensor and the GPS sensor, which will provide a timestamp for our data as well as location data. All that information will be transferred wirelessly to the server. The server will take all that information and query for weather data based on the location to get forecast weather data for that area. And using that information, we'll try to create a prediction of the potential for flashover in that area. So far to date, we've evaluated and selected the microprocessor application server and database server. We've configured our development environments and done some preliminary suitability testing of the microcontroller. We've also successfully interfaced with a third-party weather provider. Now Josh will tell you about the internal circuitry of our sensor.
So by putting probes or contacts on each end of the insulator, we can essentially treat it as a giant resistor. So by doing so, we have the ability to include a series high precision resistor, which we know very precisely. And we can measure the voltage drop across that precision resistor. Since it is in series with the insulator, it creates a voltage divider network. And by reading that voltage across the resistor, we will then know the current through the resistor, which is also the current through or across the surface of the insulator. And based on the predetermined thresholds, we will determine what is an acceptable conductance level. The next steps would be to lock down hardware, do some testing. Environmental testing will be very important for our product. And then we can continue to push our design further down to the completion road and get to building it. So thank you for listening to our video report, and we look forward to the work in the future and presenting with you.